It is difficult to achieve object-oriented tasks owing to the requirement for dealing with multiple surfaces and invisible area. Robots must turn back and change the direction of movements according to the inclination of the surfaces, and that makes it difficult to be controlled by a force control system. And handling occlusion and approaching backside require to recognize object shape, not by images but force and tactile. Humans integrate several sensory information. Inspired by this, we considered the effective utilization of image, force, and tactile data in constructing a multimodal deep neural networks model for object-oriented tasks. We proposed Model 1, which uses an image of the initial time step to approximately perceive the shape and size, and then generate motions by integrating the perception and the sense of tactile and the force. We compared the model with Model 2, which uses the continuous image, force, and tactile data, and Model 3 that uses only continuous force and tactile data. As an example, we control the robot to wipe around the outside of objects that are imitating light shades. There are 4 objects for training and 4 unknown objects for test. This is a result of principal component analysis of the internal space of the model calculated with image of initial time step. Plots of each object are clustered according to the shape and the size of them. So it can be said that the robot recognized the object feature with initial image before conducting actions. These are the videos. The robot wiped the test object with Model 1. The robot generated motions according to the object shape and size. We attached dirt points around the lower edge, which can be cleaned if more than 0.4 Newton force is attached. And we evaluate the percentage and variance of the number of wiped points. The robot succeeded in wiping all the test objects with the proposed DNN model. The average of the percentage of wiped points were the largest, and the variance was the smallest in all the 3 models. Thus, we can say that the robot could move accurately and stably with the model number 1. On the other hand, the results of Model 2 and 3 were bad. In Model 2, which always uses vision in addition to force and tactile sense, when occlusion occurs, the image data badly affected, leading to a misrecognition of the object. In Model 3, which uses only force and tactile sense, as shown in the right figure of principal component analysis, the object recognition is mixed and not correct during the movement. That results in low accuracy of wiping. In summary, the best performing DNN model is Model 1. We conclude that the effective approach to object shape-oriented manipulation is to initially utilize vision to outline the target shape, and thereafter to use force and tactile to understand concrete features while performing tasks. Thank you for watching.